Hello and welcome back to another video. And in this one, we're not going to look at Blender, but instead now we are past Blender. Now we're going to transition to coding our own rasterizer and ray tracer. And to kind of hope that makes sense is we have done stuff in Blender. Now we're going to kind of try to replicate that ourselves by code, but more simply, obviously not as complex. Um, but in, simply using code with JavaScript and OpenGL, so we can just run it. Anybody can do this that way. But before we kind of get into that deep end of coding, I think this is great that Dr. Ricks introduced this, kind of help you guys transition and understand these kind of more complex concepts. Is we're gonna use this thing called shader frog, and we're gonna go over how vertex and fragment shading works. So let's begin by going into, so you want to, come to our GitHub page for the class, github.com CS4620. Go to today section and come down to shader frog. Here we'll just go to new tab. So here we are. So we have a cylinder here, kind of, very similar to how we have in Blender, and we have other objects as well. We have sphere, cube, which we're all very familiar with. Torus, which is also a mesh that for the donut makers you would know. There's a torus knot, a complex, pretty cool. Plane, cylinder, we went over. Cone is also in Blender. This is called the Utah teapot. Um, and then you have the Stanford bunny, and this is like famous for like one of the earliest things that was like laser scanned on. Um, so yeah, so first we have this unilluminated shader. And when we get into coding, there will be three parts: the vertex shader, the fragment shader, and then we'll have another file which will be like talking with the CPU. So, and this is kind of how it'll pretty much look. We'll just add like, a couple more lines for like more complex shadings, which we'll look at later in this video. But to kind of to begin with, let's look at the fragment shader. So here's this right here, and this code, what it does is it's talking to the GPU and it's providing how many bits you want in your floating point, and this just kind of helps in, especially in shader frog. It's just that it'll take care of sending the precise number of bits, floating point value, and then here we have our what the GL underscore frag color stands for is the GL OpenGL language that we're using, and then the fragment color. And then this is the red, green, blue, and alpha values. So that's why it's red we have here. So what um so when you go to vertex, you come over here. So what this does is it takes every vertex on our object that we have and it returns where they are in the world, and then this kind of defines what the like CPU needs to tell you for that. So first we have the model view matrix, which where in the world your cube or your object has been positioned. Then you have the projection matrix, is which matrix I'm going to be using for my projection matrix it'll specify. And then position is the location of my vertex in space. And then as you can see right here, there are like these words which is called the decorators, which is kind of important, which is in front of our type, which we have here. Matrix 4, size of 4, vector 3, whatever the case may be. So the uniform is that it'll be uniform across all vertices in my model. And then attribute is it's the attribute of a specific vertex. So position of the vertex is it's gonna change. Um, so what what's happening in this line of code right here is first we'll look at this part is we take the position of my vertex and turn it into a vector 4. So take this position and turn it into a vector 4 making W0, and then we multiply by the model view matrix, which tells me where in the world I moved my model, and then multiply it by the projection matrix, which will give the GL position. Um, so the vertex shader runs first, then the fragment shader. So the vertex shader, once it figures out where the 3 points are, then 3 points in the triangle are, because from what we have learned is that it rasterizes it triangle by triangle. So then it figures out which pixels fall in the boundary of that triangle, and then it'll pass those pixels to the fragment shader, and then the fragment shader will color it based on what color we choose. So, to kind of better give you an illustration of the model view matrix is, let's go to Blender real quick, and obviously turn on screencast keys, even though it's not necessarily important for this demonstration. So, we're in object mode, and if we move this cube by pressing G, see that little dot? It's in the center of the cube. So we only moved the center of the cube, and Blender is keeping in track the offset from the origin. So the vertices are still, 1, 1, 1, negative 1, 1, negative 1, negative 1, negative 1, according to Blender. So it's kind of like how the model view matrix tells where objects move the center of the object. But then when you go into edit mode, and then you Command Z, move it, okay, and then go into edit mode, and then we grab it and move. See, the center is still in the origin, but um, the values of the vertices are changed. So that's kind of how that works. So now let's get back into our shader frog, and in order to illustrate something real quick, which is the projection, to kind of show how so we'll go to our fragment shader, kind of manually show this real quick, if it'll let me edit. There we go. You have to click edit source, and then come down here. We'll do a matrix of 4 called projection, and set it not in the fragment shader. Oops. Command Z. I'm just gonna refresh it. Okay. All right. Go to our vertex shader. There we go. Go here. Do a matrices of 4 called projection. Again here. 1 point. So if you understand some of the math that Dr. Ricks went over, this is kind of that in code. So now we'll do 0 vector of 4. Okay, then we'll just copy this over. I spelled it here. We need 0, 1, 2, 3. So this should be it. 1, 2, 3. And then change this diagonally. And then if we change this projection matrix, so now we're kind of instead of getting the projection matrix from through OpenGL, we're manually doing it. Nothing is showing because we haven't put the Z value here. So if we do 1 here, again, that won't do anything. That is because 1 point. hold up, 1 point. Okay, that is because in OpenGL the z-axis. So there's like two different paradigms that Dr. Ricks discussed, and what is relevant to us is that in OpenGL its z-axis is negative. So if we change this to negative, we have our object now. But it's just that um, since the viewport is not square, and then we have to kind of mess around with this kind of guess, which is not ideal. But it's just to show how it kind of works. And um, so this demonstration was to show how the projection matrix works in Shader Frog under the hood. Um, and so we can get an idea of how it will work when we actually code it. This is kind of how we'll code it. Um, so yeah, that's it. So basically, what this is to show, like this is like the most basic uh, shader. It's just rasterizing our object. But then now we'll go to something a little bit more complex, like the next step, which let me open it up here. All right. So now we'll go to the unilluminated shader with variable uniform. Here now you can see we have a new option, which is to change the color. So if we go to a vertex shader, it looks the same. But then when you go to a fragment shader, now we're using an external variable that we can pass in a color, kind of like in Blender, or if we go like passing in a material, like so. So that's it for this shader, kind of the next step from our base one. And then next we'll go to our normal shader. Dr. Ricks has talked a lot about normals while we're in our Blender section. But here, if we go to our vertex, the big uh, change would be that now we calculate the normal and then pass it into the fragment shader by having it here. And now you can notice we have a new decorator called varying. And what this is, it varies for every pixel of the fragment shader it touches. And that you can kind of see here where it's varied. And the reason for that is it colors it based on the normals, X, Y, Z axis that we have. X, Y, Z. Based on that, it's shading it. So it passes in the normal, and then you just have the alpha value. For the RGB, it just passes in the normals. So, and then, yes, there we go. The model matrix here. One more new thing that's taken into account when calculating the normal is where in space the model is. So, so that's it for this shader. Now let's move on to a little bit. The next step is having some lighting. So now you look up and there's a light. So that's it. That's our light right there. Kind of like how we had in Blender. And then this is the direction to the light. So we can change it and you'll see now the light moves and then everything else, like how the light illuminates or it changes. And this is the color, I believe. Right now it's just black and white, which we'll get into why in a second. Um, the light strength is how much light will land on the object, and we take the dot product uh, of the normal. So we can use the normalize function, which is convenient, and we can just take the dot product function. And if you go to the vertex, pretty similar, except it adds the position, which doesn't come into use for us right now, but you can see now we'll use the light strength here. And one key thing here is even if you pass a -1 color value, OpenGL will make it 0, which is why even under it, instead of it erroring, it's just black. So now let's move on to the next step, is diffuse plus ambient shading. So in this now, we're adding a ambient color in the fragment shader. So as you can see, it's pretty similar, but now we have like a test variable that we're passing in. But then the main thing is that, right, just trying to enlarge so you guys can see. So now we get the ambient color, and then now we'll pass that in with the light strength in the fragment color. So we can change this. Let's see, look at that. We can change it. The ambient color. That's the main color, and then the ambient color we can change it to something. Let's see, make it more apparent. Yellow. That's too much. Look at that. So now the ambient light is more yellow, and then we can change the position of this. It's too far away. Now you can see there's yellows over here. There you go. So yeah, so as you can see, there's not like a huge change. Basically, the first thing that we looked at was the base. From there, you just add like one line and then another line, and then just add new, and then move on to the next step. You can change, like as I mentioned, um, you can change the position of the direction of the light. So let's move on to the next step, which is a point light. So with this, if we go to the Vertex shader, it's pretty similar, but then now we pass in the position like we had looked at in one of the previous shaders. But as you can notice, now we actually use it, and why we do that is we so in order to get where in the world the pixel is, which is this position, is where in the world the pixel is, and then you subtract it from the location of the light, and then you know passing the ambient, so light positions here. So and it's kind of similar to the one we have in Blender. So now let's move on to another one, which is shader with UVs, and that's because the three important things are position, which we looked at, and normals, but then we haven't looked at UVs. So that's what we're going to look at now. So as you can see, I think Dr. X mentioned UVs a lot when we were working in Blender. If I'll show you a quick example, is we go to shading, go here, Shift A, search UV map. We have discussed about UV mapping in Blender, and then we pass it in here, and there you go. You can kind of see how the UV mapping is for this cube. So come back into here. Um, so with this, we go to our vertex shader. Every vertex has UV information, and then when you go to the fragment shader, the color is based on the UV. So now we'll go to another example, kind of building off this, I believe. Grid UV shader. Yep. So with this, we're making like checkerboard. You can make like checkerboard pattern, and then it changes with time, as you can see. If you go to fragment and calculate light strength, changes with time. And the fragment color, there you go. And I think that's about it. This is like the more complex that we have looked at, but as you can see, it's still the same. Look at that, same line of code. And then this one is also was started using after like the second or third shader we looked at, is to get the position of where in the world the pixel is, and then we added the UVs in the last one, and then normalize after like the third shader we looked at. That's also been there. So basically, you just start with the first shader, then add another line, and then slowly add each of these more features to every coming shader. So yeah, that's think that's about it for this video. So now you can kind of see how what we did in Blender and then how we can kind of do it using code. And then these are the two important parts that we'll be coding, which is Vertex and Fragment shader. Vertex is going to be pretty lightweight. As you can see, there isn't much that changes with it except you have like 3 constant lines at one point, and then the fragment is what's going to really change a lot based on how you want your object to look like. So, right, I believe that's it for this video. Thank you.